Hey, welcome to my channel Industry 4.0. Today, in this video, we will learn about Solidity global variables in detail. Please like and share the video and subscribe to my channel. So, let's start. The var type variables. One solidity type is the var data type, as var is a special type that can only be declared within a function. There may not be a state variable in a contract of type var. The implicitly typed variables are those variables declared with the var type. Due to var doesn't represent any type explicitly. This notifies the compiler that its type is reliant on and strong-minded by the value assigned to it the first time. It cannot be changed once a type is determined. The compiler chooses the final data type for the var variables instead of a developer stating the type. This is so fairly possible that the type is determined by the block. Difficulty: current block compiler may not precisely be the type predictable by code implementation. Var may not be used with the explicit usage of a memory location. An explicit memory location wants an explicit variable type. Variables hoisting. Variables where need not be declared and initialized before using the variable are hoisting a concept. The variable statement can occur at any place within a function. It can appear straight after using it. This is recognized as variable hoisting. The Solidity compiler excerpts all variables stated anywhere within a function. They place them at the top or start of a function. We all know that declaring a variable in Solidity also resets them with their own default values. This safeguards that the variables are available through the function. Variable scoping. Scoping mentions the obtainability of a variable within a function. This is called a contract in Solidity. Following two locations are being provided by the Solidity where variables may be declared. Contract level global variable. They are also known as state variables. They are available to all functions including constructors, modifiers, and fallbacks within a contract. They can have a visibility modifier attached to them. Function-level local variables. This is fairly informal to know function-level local variables. They are simply presented everywhere within a function and not outside. It is significant to know that state data can be viewed across the entire network regardless of the visibility modifier. Following state variables might only be modified using functions. Public, accessible: these state variables directly from external calls. A better function is indirectly made by the compiler to read the value of public state variables. Internal: these state variables are not accessible directly from external calls. They are accessible from functions within a current contract and child contracts deriving from it. Private: these state variables are not accessible directly from external calls. They are also not accessible from functions from child contracts. They are only accessible from functions within the current contract. Block and transaction global variables. Solidity delivers contact to a few global variables. Those variables are not declared within contracts. They are accessible from code within contracts. Contracts directly cannot access the ledger. Only miners can maintain the ledger. Though, Solidity offers some information about the present transaction and blocks contracts so that they may utilize them. Solidity delivers both block as well as transaction-related variables. Cryptography global variables. For hashing values within contract functions, Solidity offers cryptographic functions. There are two hashing functions: SHA-2, SHA-3. The SHA-3 function changes the input into a hash based on the SHA-3 algorithm, while SHA-256 converts the input into a hash based on the SHA-2 algorithm. Another function is also available that is known as KECAC256, which is an alias of the SHA-3 algorithm. This is optional to use the KECAC256 or SHA-3 functions for hashing requirements. Address global variables. Every address either that is externally owned or contract-based has 5 global functions and a single global variable. The global variable related to the address is called balance. This delivers the current balance of Ether in way offered at the address. The functions are as follows. .transfer, UN256 amount. This function sends the given amount of way to address, throws on failure. .send, UN256 amount, returns, bool. This function sends the given amount of way to address, and returns false on failure. .call, returns, bool. This function issues a low-level call, and returns false on failure. .callcode, returns, bool. This function issues a low-level call code, and returns false on failure. .delegate call, returns, bool. This function issues a low-level delegate call, and returns false on failure. Contract global variables. Each contract has the following 3 global functions. This, the current contract's type, explicitly convertible to address. Self-destruct, this is an addressed recipient that destroys the current contract, sending its funds to the given address. Suicide, this is an addressed recipient also alias to self-destruct.